bit before I started my PhD because I was looking for nice places that worked on like human-centered AI type of stuff. So yeah, very nice. So today I'll talk about my PhD work and also just some my general thoughts and vision on the topic of human AI co-learning, and also a bit how it relates to meaningful human control, because I already had a few discussions with some people and thoughts, so I'm just well, excited to discuss it with you. So the title of my presentation is also Growing Mutual Understanding and Smooth Collaboration. So is that what co-learning can bring us? So to give a bit of background about me and my vision, so I believe very strongly that if we want humans and AI agents to kind of live together symbiotically, they need to collaborate as team partners. And I think it is important that we focus on the different strengths of humans as well as AI agents to really ensure that they can empower and support each other. And I think that can help us to make optimal use of the qualities of AI agents, but also while maintaining respect and appreciation for the qualities that we as humans have. And I think probably many of you agree with me on that. So I have a background in industrial design. I originally studied industrial design in Eindhoven, but I also did a master's in artificial intelligence in Utrecht University. And I think this combination causes me to look at AI and robotics really from a very human-centered perspective, but also interaction-focused. So what happens in the interactions between systems and people. So my PhD is about co-learning, human AI teaming. But I focus very much on the complexity of interactions that appear and emerge if you create such situations. So if we talk about co-learning, and start to think about what does that mean, I always start with, okay, what does it mean if we have two people that collaborate with each other, but that are very different? So they might speak a different language, or they have different ways of behaving, and that might mean that they don't understand each other from the get-go. So what we do as humans to cope with that is we adapt to each other. We maybe learn each other's language, but also we change our behavior, and we do this in a very reciprocal manner. So both of us do that, or if we're in a larger team, everyone does that. That of course raises the question: what happens if you're in a team with a machine, a robot, AI agent, whatnot? Does it understand us if we talk to it and behave? Well, probably not immediately. So what do we do? Well, you can, of course, say, well, we just put the human behavior into the machine. So we let the machine adapt to us, and then we'll be fine. That's perfect. But of course, there's something a bit odd about this. The machine doesn't have any hands naturally unless we give it to it. And I think also, of course, the inside of our brains are very different. So it feels a bit odd to let only one completely adapt to us. So I always try to argue that you need this kind of very reciprocal and mutual adaptive learning process to really get to like understanding and become a well-functioning team to get attuned to each other. So when we talk about co-learning, well, what comes to mind is a process in which two or more parties or systems change their behavior and or mental states while interacting with each other over time. When you look in literature, there are several terms that you can use to describe this. So for example, co-adaptation, co-learning, co-evolution. What do they all mean when compared to each other? So I think that they differ in terms of time span. So if you talk about adaptation, that feels a bit like something that happens like ad hoc, implicit, short time span. Co-evolutions, like this huge, long process, and co-learning is somewhere in the middle. I think they also differ in terms of intentionality. So co-evolution is clearly unintentional, just this process that happens that we can't really do anything about. Co-adaptation can be maybe a bit intentional in the sense that you want to, well, be better at something or improve collaboration or whatnot. But at least the actual changes can be relatively implicit. And I think co-learning is more intentional. So we really want to improve the performance of a team. We want to improve our experience, and also that this development is sustained over time and context. So it's not just we adapt and then we adapt again and adapt again, and this is just a continuous process. Of course, it is somewhat of a continuous process, but if we adapt to something that works well, we maybe also want to keep that and keep doing that. So in relation to that, we can also wonder in general, what does it mean to learn? So probably many of you have either done the UTQ or some graduate school courses on teaching, so you might know this. So we can say learning means to change behavior, which very behaviorist perspective, we just change our behavior. We can also say learning means to acquire knowledge, the more cognitivist perspective. With the computer metaphor, we just gather some knowledge. But the more constructivist perspective, and one that we kind of usually try to see, is also that it means to build meaning and try to make connections between behavior and knowledge and all these different things. So to relate that to what I just said about co-learning, for me, co-learning consists of different parts. So yes, it is also co-adaptation, which means these implicit and unconscious changes in behavior and interactions. But there is also there should be some kind of feedback loop. So this is a bit more related to acquiring knowledge, but it is specifically about connecting the two. So can we become aware of implicitly developed behaviors? Can we reflect on them and then see if we want to use them in the future? So this is the kind of the definition of co-learning that I go by. But yeah, how to actually research that, how to facilitate such a process, what are the benefits, what does it mean if you actually have a human and a robot or human and an AI system? So this question is a very big part of my PhD research, just how do we actually research this? So I'm going to give 2 examples of experiments that I did that were an attempt. So one is one that I already did during my master's in industrial design. With a focus on leader-follower dynamics, where I created this task where people had to navigate from one end of a field to the other side with a robot on a leash. And the idea was that they had to do this as quickly as possible, but in the field there were hidden objects, and the robot knew where those objects were, and you could get points by finding the objects. But of course, finding the objects costs time. So this was a Wizard of Oz experiment. So it was really exploration of behavior. How do humans deal with this conflict of constantly trying to decide, okay, do I follow the robot or do I go my own way? And kind of moving back and forth between that. And it's very interesting to see what kind of behavior comes out of it. So some people really only follow the robot. Some people really like lead and pull the robots towards the end of the field. But there's really all kinds of behaviors in between. Where they closely watch the robot and see where does it go and then pull it that direction that the robot wants to go, or all kinds of other different behaviors. So another experiment that I did is in a virtual task that I did last year as part of my PhD, where the focus was more on observational learning and adaptation. So I created this task that is an urban search and rescue kind of task. So you had to save a victim that is buried underneath a pile of rocks. And again, there are some differences in capabilities. So the virtual robot could pick up large rocks and break them into pieces. And the human could only pick up small rocks, but the robot was very unaware of gravity and those kind of things. So it might just pick up a lower rock and then everything would collapse. And in this case, the agent actually used a reinforcement learning algorithm where it tried to decide between different rule-based strategies. And the human was very unaware of all those strategies. So kind of on the go, the human had to figure out what are the different strategies of the robot and implicitly pick one to kind of focus on. And then hopefully the robot would also learn to use that one, which is also what sometimes happened. So both these experiments focus very much on the implicit part, so the more co-adaptation. So to explore, okay, what happens if you put a human and an agent in this environment where there's this tension and they need to learn to understand how to work with the other. So some things that I learned from that is, of course, if you create a task like this, you need a task and environment with interdependence. It needs to be useful to collaborate. Why else would you do it? So you need to provide the opportunity to have this implicit adaptation in learning. And what was very important for me in terms of research purposes is that it's possible to have different strategies. So if you have one clear optimal solution, then it's very easy to converge to that. But the real world's often not like that. The real world's often dynamic. So tasks change, you have preferences. So I deliberately design tasks that allow people to choose their own way of solving the task. So for the second experiment, so it was also important to have a simple enough problem such that the, in this case, reinforcement learning agent could learn in a few rounds, so quickly, while working with the human. And you could also say maybe it's important to have like a real life domain, because it should eventually also scale, of course, to the real world. But what I think is the kind of key thing, or what I thought was most important, is to facilitate the emergence of interaction patterns. So what do I mean with interaction pattern? I mean with that basically a sequence of behaviors or interactive behaviors that can be distinguished as kind of a unit of behavior that repeats itself. So if you come in a certain situation, then there's a certain type of behavior that you show, like a strategy. But then one that is not really decided beforehand, but one that emerges. So we often use examples from sports. So for example, football or any other team sports. When you know each other really well and you've done the game for a long time, you know kind of strategies of how to deal with specific situations that you encounter. And at some point you can also reflect on those and be like, oh, let's apply that when the opponent does something. And so, okay, so maybe not go to the figure immediately. So for me, what I mean with when co-learning is co-adaptation and this feedback loop and reflect upon that, it is especially this. So something emerges, some kind of behavior. Can we become aware of the fact that that emerged? And can we then also name that, say, this is, we call this behavior X, and we're now in a situation where we should actually apply behavior X. And then you can keep that behavior and sustain it over time. So then we can learn. And it's also tying that behavior that we felt and experienced to the knowledge that it works well, and thereby building some kind of meaning. So in order to facilitate that, what I'm currently working on as the next step is to build an ontology that is able to save that kind of, to store that kind of information. So patterns of behaviors with requirements for context in which they hold or in which they are expected to be. And a way for a human and an agent to communicate about that. So currently I'm focusing on the left scenario, so where we give human initiative in that, because it's a lot harder to also let the agent or robot recognize certain patterns. So the idea is that, okay, the human and the robot, they collaborate, they interact, they adapt. And as a consequence of that, inevitably, there will be some patterns of emergent interaction. And then in this case, a human should kind of signal that or recognize it as such, and then save it in the ontology by communicating to the robot. Meaning that the robot can also, in its when it performs the task, look in the ontology and see, oh, in this situation, my human expects to have this behavior, and expects me to have a certain kind of behavior. And then, of course, ideally, what you would want also is that the robot can also signal these, has initiative in this. So the robot can also say, oh, maybe you haven't noticed, but I see a pattern in how we behave. Maybe this is a useful pattern. So yeah, so that is something that I'm working on or trying to achieve, also with different students. Of course, it's not trivial. And then a question that arises for me, I think, and hopefully also for you, probably, is, okay, but what does that then mean for meaningful human control or control in general? Because, well, co-learning also means to fail. Learning means to fail always, right? And I think it was very clear in some of my experiments. So in this one, some rounds, so participants did this for, I believe, 5 rounds. So sometimes they were really slow. Sometimes they walked all over the field to find all the objects, and their overall performance was just really bad. Or in other tasks, this can have even more severe consequences, meaning that maybe the robot drops all the rocks on top of the victim in this case, which is not really something you want. Or we take a very long time, so maybe the victim is not very happy being underneath the pile of rocks all the time. So maybe eventually after a certain time it becomes better. But yeah, in order to get there, you also need to fail. So you need to let go of some kind of control to allow for that failing. So what does that mean for a real world example? It's of course hard to imagine. But I think that the process can have the potential to facilitate the emergence of meaning. So if we talk about, well, we have certain behaviors that emerge. Once you can name those behaviors and be aware of them, reflect on them, maybe that is something that we can call meaning. So maybe if we have a certain modus of collaborating that is there in the end, maybe that is more meaningful than anything that we can design, because well, we learned to understand the other in a certain way. And I think that is how we humans often work. We learn to understand by making these connections over time and learning about the other, slightly changing our behavior. So kind of also to finish that up, I think there are many questions that you can ask, but I wrote down a few that I think are important. So first of all, how do we cope with human failure? So we're very well familiar with the fact that humans fail, and we accept that also to a certain extent, and we have methods with which we cope, how we cope with that. But what if we are in a safety critical environment? How do we cope with failure? Well, some people in the military might probably say we don't fail, but that is of course because they've put all kinds of protocols in place, but also because they train a lot beforehand. So can we use similar strategies to deal with or cope with machine failure? That also means we need to change how we look at that, and we need to start accepting that machines sometimes fail, but we need to make sure we have strategies in place that help us control for the machine failure, while the machine maybe can control for our failure. Of course, also a very philosophical question always, when do we start qualifying behavior as meaningful? Of course, touches on in general what is the definition of meaningful human control, but I think in general, what is meaning, and is it something that we can create or find through these exploratory processes of co-learning and whatnot? And then one that I always, well, this is one that I don't necessarily ask to wonder, but ask to trigger people also. What does it mean to optimize performance in complex and dynamic tasks? Because of course, a lot of work we do in AI and robotics and whatnot is focused very much on optimization. But if you connect that to a term like meaningful and to a process like co-learning, where you have a dynamic environment where people have different preferences and there's not clearly one solution to a task, what does it even mean to optimize? So those were the three questions with which I wanted to conclude the presentation and hopefully open the discussion. So I don't know if any of you has questions, but otherwise, let's just start the discussion.
Great, thanks Emma for this presentation. Super cool. Yeah, so we're opening up the floor for everyone else. So please unmute and have at it. Curious what comes out. Go for it, Lucia.
Yes.
Yeah, thank you very much for the presentation. I really liked it, and also really like the slides, which is not a kind of common thing for me to appreciate also the slides. Well, so I also like a lot the questions and the kind of the fact that you try to make a connection with meaningful human control. What does it mean? What happens when we move from like the lab environment, the simulation environment, to the real case scenarios? And I think it's really what we should be asking ourselves. And related to that, do you think that this work can have like an anticipatory power? Like, do you see it like possibly, as you are saying, it helps understanding emerging interactions, emerging patterns and behaviors. So do you see it in a positive way that it might create the space for anticipating consequences and effects that we might have in real case situations?
Yeah, I think so. How I look at it is, as I said, it partly is about the perspective that we have on what does a machine or an AI system do, and do we require it to not fail? So I think, yeah, looking at these kind of processes is really for a very big part reflecting on this, like how do we look at this relation? Allowing a machine to fail, also accepting that a process like co-adaptation and co-evolution is maybe inevitable, because humans are adaptive anyways, and if we then start creating adaptive machines, whatever that may be, then co-adaptation is inevitable, I guess. Do research work that also appreciates that, because I think a lot of the time we assume either the human or the machine to be static, which is almost never the case.
Yeah. But like, do you think that the kind of failure that you imply and you might experience in simulations and lab environments might be representative of what can happen in real applications, or do you think there will be still a lot of, well, probably it depends on the case and the kind of simulation you build.
Yeah, and I think there's a difference between the actual failure and the process of like accepting that there will be some kind of failure.
Yeah.
So if you look at how humans collaborate in safety critical environments like the military or whatnot, they also can't anticipate beforehand exactly what the failure will be, but they can anticipate that there will be a risk of failure.
Yeah.
And they can put strategies in place to make sure they know how to deal with that failure. And I think like a process like co-learning or something is a way to start understanding how to cope with that. So if you train together and you learn, then things will go wrong, and then you can develop behaviors, interaction patterns that enable you to deal with failure situations. So in a very kind of not real life example, so in the experiment that I did, like with the virtual environment with the rocks. So a type of failure that occurred there is that the robot broke rocks in such a place that they then dropped on the victim. So some participants started creating behaviors where if they suspected that the robot was going to do that, they started placing like a little bridge of rocks over the victim to, well, make sure there wouldn't be, to prevent damage. So then you can say, okay, well, they have a very concrete strategy to react to the concrete failure, but part of it is also looking at the robot and understanding its behavior to an extent where they could know when it was going to fail, for example.
Yeah. Okay, thanks.
Great, thanks. Does anyone else have a thought or a question for Emma? If not, actually, I have a question in the meantime. So I think it's interesting points also that you make, Emma, and also in terms of meaningful human control. One of the issues that's also present is the rate of learning that we're considering, right? So sometimes either the human or the robot is faster in terms of learning a certain pattern or a certain, preferred action. So, for instance, also in your own research, how do you see that happening? So, in terms of, for instance, the human still has a little bit of control over what interaction pattern goes into your ontology set, for instance, right? But the robot can be way quicker. And how do you? So, in your view, how would you cope with this, or how would you handle this? Is it a problem at all?
I think it's a very good question, and I think it is a problem. So I think in my experiment, I try to kind of force the agent to learn at a rate that is similar to the human. So, for example, people played the little game 8 times, and I had to ensure, and with 2 different scenarios, so 5 times one scenario and then 3 times another. So I kind of had to ensure that the robot would learn something some kind of strategy or behavior within 5 rounds, such that the human was also able to kind of see that change and anticipate. But yeah, in real life, the question is, of course, do you want to enforce that? Because learning is a very strong behavioral cue also. So if people notice that the robot changed its behavior, then that will lead them to maybe also change their behavior. And ultimately, if you want to have a balanced collaboration where indeed both agents have some kind of initiative, at least in the type of behavior that eventually emerges, yeah, if one is much quicker than the other, that is going to be very difficult. So yeah, I don't have a solution for that. I think in my current work, I just enforce it as much as I can. Yeah.
Yeah, no. And I guess then sorry, David, that's where the mutual understanding, I guess, what you also alluded to, is going to be really important to make sure that at least we can still understand what has been learned at some point, to some extent, I guess. But you know.
Yeah, that is one of the big challenges in this kind of work, is you need to make sure that the human sees that the robot learns, because otherwise they'll just be like, this robot just does whatever, I'll do my own thing and not care. So you need to create this empathy, sort of. Yeah.
I just wanted to make a comment on what you just said about the learning rate. Oh, maybe I'm bypassing Evgeny. I see a raised hand. So
you just raised it.
No.
I just raised it. Ah,
Go
okay,
ahead.
good. So actually, I think what you did is a prime example of what in the military domain would be called putting the system under meaningful human control. So I'm not quite sure, but so let me check with if the analogy makes sense. So in this case, it's learning, right? That the speed of learning is kind of made at the same order of magnitude, and in this case, that learning also, I think, has something to do with the initiative, with how quickly the robot might take initiative. But there I'm not quite sure, because I don't understand it well enough yet, perhaps. But so in the military domain, they're very scared of systems taking initiative by themselves, and perhaps learning much more quickly what the target is that they need to be searching out, and how to identify friend or foe or whatever, and do that much quicker than humans. And that therefore these systems should then also make the call to, press the button. And then there's this disparity in I guess response time, that says, well, yeah, there's maybe advantages of having military advantages of having the system being not under meaningful human control, because then you're much faster. Yeah, and then and that's the fright, right? And then maybe if the system makes an error, my God, how could you prevent that? Or right? So
yeah.
So I think what you're describing is maybe correlated somehow, that you're saying, well, right now I imposed the learning speed to be in the same order of magnitude, simply because I want to make sure that the interdependence stays. And so I just wanted, so that's an observation, a thought that came up listening to you, and maybe I'd like to hear your reflection on that.
Yeah, I think it's a good thought, in the sense that, of course, you can also adapt the agent or the robot beforehand. And by indeed enforcing a certain learning speed, you adapt it beforehand versus real time. But I think it also depends a bit on control versus meaningful control. So, of course, maybe if the system can take initiative, then that means the human's not in absolute control, but it may still be meaningful control if we decide, okay, in certain circumstances, we allow the machine to take initiative because we know it can perform better and within the boundaries of what we find acceptable. So yeah, this is what I always wonder about. So if we say meaningful control, that means we don't mean absolute control, right?
So yes, yeah. So if that's a question, so then we're at the heart of our research topic, Emma, and so I think there's still debate around that. But yeah, but so maybe indeed my perspective is that control indeed is then not absolute top-down control, that you can control every nitty-gritty detail necessarily. Then a lot of the systems are out of our meaningful human control anyways.
Yep.
It also doesn't mean it needs to be top-down control. It could also be kind of bottom-up influencing, perhaps. Sure. And in terms of meaningful, it also means that sometimes we implement systems that in principle allow people to overrule them, but in practice,
sure,
are so boring and are good enough that people don't even, actually de facto stay in control. And then therefore it's a kind of, but it's possible, but it doesn't happen. And so that's also not meaningful control. And so I spent now quite a lot of words describing what meaningful human control is not. And I gladly drop the mic and give the floor over to people to define what it is.
Yeah, I mean, you can have different, talk a lot about it. So for me, a very important component is kind of what I started with. My vision on this is if we collaborate, that means we need to appreciate the qualities that a system has, and we need to appreciate the qualities that a human has, and be realistic about who does what better. And then, of course, as a human, maybe sometimes we say, okay, we sacrifice performance over something else, which is maybe also performance, but another kind of performance. But then that also means that sometimes you need to let the machine do its thing because it is simply better at it.
Yeah.
But what does better mean? That is then, of course, another question.
And Evgeny, if you allow me one more response to that, is that this discussion also reminds me of work we've been doing in the automotive domain, where it's actually who's better is very contextual, so context dependent, and that means if you know a priori. In what context which would be better, which system would be better, life would be easy, but quite often contexts evolve unpredictably and perhaps even unknown. And then there's this tendency that because we look at specific parts of the context, we can say, well, there the automation or the robot can do much better, so we should do it there. And actually, what this discussion makes me think of is that also there you might say, actually, maybe it's not overall better the way we design our collaboration system, but maybe in a larger scheme, if we consider more context, maybe then overall is better rather than in one specific context. So maybe kind of the widening of the scope of your context is actually maybe needed to make the distinction between what's good performance. That was your third point, performance in complex dynamic systems. So that was another thought. That maybe different contexts need to be put for your collaboration system in order to find out its weaknesses and strengths.
Yeah, I agree. And for me also that maybe it's sometimes too subtle to determine a priori, and that is why we need to look at co-learning, right?
Exactly.
Because it's an ongoing process to figure out the subtleties.
Yeah. Good. Okay. So, Evgeny, thanks for the nice discussion.
Hi, Emma. I was curious about that last that third question that you posed on the last slide. So first of all, I was curious if you can share, so from your research, like what kind of experiences you've had where you have seen this question really like play out with where then one would struggle to say, well, what is optimal? Because maybe like it's hard to define something that is optimal, or the nature of the problem and people's perspectives makes it hard to even talk about one optimal thing. So I was just curious if you can share some experiences that you had with it.
So one that we basically almost always find if we try to do some kind of co-learning experiment is short-term versus long-term performance, and then subjective experience and like human understanding of what is happening versus performance. So very often performance is something you try to measure to see, okay, we now made some kind of co-learning process, does it increase performance? And basically in all the experiments we've done, it's very difficult to, within one experiment, see increase in performance. Sometimes it might even be a decrease in like, and then with the performance here, I mean objective task performance. So how long does it take to finish the task? How much did you hurt the victim? But if you then talk to the people who used the co-learning versus people who did not, they have a much better understanding, at least in words, of what the system did. They can explain it much better. They sometimes, well, they feel like the collaboration was more fluent, but maybe you don't immediately see that in objective performance. So that is then exactly the challenge. So the claim we usually make is, well, it makes sense that maybe you don't immediately see performance increase because the tasks are sometimes complex and humans try different strategies that sometimes they're not necessarily efficient. But well, we kind of assume or hope that in the long run, because collaboration fluency increases, because understanding increases, in the long run, we will have some kind of performance increase. But then that is very hard to measure, of course, and to kind of prove. Then you need long-term experiments. So I think that is where we find the challenge. So for that reason, I measure collaboration fluency usually. So it doesn't necessarily mean that I let my agent optimize for that. Sometimes, I mean, in my experiment with the rocks, for example, the agent did try to optimize for time and victim harming. That doesn't mean, because you're in the team context, doesn't mean that it actually works, so that actually improves. But it was just to give the agent something to optimize for. So yeah, I think collaboration fluency is an important thing, but I think a lot of the things you want to optimize for are very subtle and qualitative, making it hard to optimize.
I was just gonna say, because like it touches something that I'm looking into in my own work, but exactly what you just said, that the qualitative aspect, which can be so important in many contexts, whereas by nature of mathematical optimization, and if you want to put into algorithm, then things need to be reduced somehow into numbers. Mm-hmm. And then there, in certain contexts, there's a tension. There's a tension there. But what I mean, just as a follow up to that, like what part of what many of us are figuring out as people coming from originally different backgrounds, kind of common ways of working together, and different disciplines have different philosophies of approaching a problem. But like connecting to the previous question, where do you see what are some of your what are your views on how qualitative research plays a role in informing these design decisions that we make, engaging with people in a qualitatively rich way, in a way that you cannot just present in a diagram necessarily, with some numbers, but you really need to get into like interviews and the nuance of what people say, and there might be more than one interpretation as to
Yeah, I think it's essential, but it's also how I was raised academically, because when I studied industrial design, we basically, the research that I learned was more qualitative stuff. So for me, doing my PhD, I'm constantly also trying to search for the right way to combine qualitative research with more traditional quantitative analyses, or doing experiments where you have a control and experimental group, and trying to combine all of it. Thereby also trying to convey the value of the qualitative stuff to people who are not used to working that way. And trying to be very systematic in that to make sure people believe what I say. Yeah, I think it's essential. And I think people should maybe always use mixed methods to really understand complexities of things like this.
Thanks. I can definitely agree with you on that. Yeah, thanks.
Yeah, thanks, Evgeny. Actually, Emma, oh, Herman, you're first before you go for it.
Thanks, Nick. So thanks, Emma. That was super interesting and fascinating. Although I have to admit I didn't understand everything, but I had a question about the 2022 experiment that you are planning to do, or probably already have thought about a little bit. So, there seems to be an asymmetry between the human and the robot, and of course it's very interesting that if you have a way for the robot to, or the AI system, to find out that there is an interaction pattern. So that seems very challenging, but I think manageable in some sense at some point, at least not for me, but perhaps for you. But what I find difficult to see is how you could, if you have found such an interaction pattern, how you could communicate to a human what kind of interaction pattern it is you have found, and so how can you communicate in a meaningful way to the human that there is this pattern, and yeah, so in a way that is useful as well. So did you have any thoughts on this already, or?
Yeah, I have some thoughts, not a solution. So it's very ongoing. So I have a master student who's starting just now in general to think about in general these communication questions. So what kind of dialogue or communication modalities, etc., should we use for this type of communication? And he's just starting. But I think what I and also what my supervisors really strongly believe is that you need a basic common vocabulary, and that is what I use my ontology for. So I create an ontology, so a knowledge structure that has certain concepts in there, like, okay, what we have actions and we have objects, we have actors. I create kind of like a template in which you can describe the interaction patterns, meaning you can describe certain context factors and then basically a sequence of actions. Of course, in reality, it's a bit more complex than that, and maybe you also want conditionals in there and expectations and whatever. But this is like a first way to try to achieve it, and then just assume that as the common vocabulary. So we create that ontology. We make sure the robot can use it, or the agent can use it, and then we make sure it uses a vocabulary that is understandable to a human. And of course, in kind of an ideal world, you would have to kind of ground all these concepts. So there's of course a lot of research on like grounded situated communication, where you say, okay, this is a mug, now you know what a mug is. And I mean, what would be very cool is if you were to ground all the concepts in an ontology in that way. But currently I assume that has been done, so I just have an ontology that is a given. So you need the common vocabulary. My tea is coming in. Yeah, so currently I can show you, but maybe something. So what I've done for my own next experiment is to just create a little graphical user interface that allows the human to describe behavior. It looks like this, but it's just something I designed. So you have so basically just look at the right side of the screen. So you have this little form that is just like, okay, a situation contained and what did we do? So you can say, for example, a situation contained large rocks at the top of the rock pile. And in that situation, basically we let the human maybe stand still in the side of the field. So we let the human wait, and then the robot can use that as a signal to then pick up that large rock that is in the top of the pile. So this is really based on that experiment. Yeah, so this is just a first suggestion of a communication thing, because there's a lot of questions, of course, like, do you want an interface? Do you want natural language? Do you even want language? Can you do this in a more haptic manner, or whatever? And it's all very dependent on context also.
Yeah, thanks. Fascinating. And that really helps me understand as well how you think of this. So really great. I would love to read the thing that you already work on, and especially also your your next paper. So
yeah, sure. Yeah, so I have papers about the experiments that I used in my presentation. Yeah, for this I don't have yet, but I will be running a little experiment where people have to watch videos of the previous experiment and use this graphical user interface to describe patterns that they see of behavior. And once that is done, I'll probably write something about it.
great. Thanks.
Great. Thanks, Alan. Sharwin, I saw that you...
Hello. Yes. One question ago, you said that, oh, we should definitely encourage mixed patterns of solving this co-adaptation problem. And then Harman talked about how we can basically asked about how we can basically describe or transcribe the behavior we are seeing, or how the machine is trying to recognize this collaboration. Do you think it is also valuable to do this in systems where these systems which implicitly do this? So optimization systems such as, let's say, a very common example, YouTube recommendation, which optimizes for something really simple, money. So it only shows people more ads if you watch more ads. If you are always clicking the skip button, it will show you less ads. It will show you addictive content when it knows that you can watch addictive content, which is at night at 3 a.m. when you actually feel like it. Or these really, let's just say, toxic actions. Do you think in these situations where an algorithm automatically just makes user profiles and knows how to act to just like generate more revenue, no matter where on earth on what kind of content you're consuming, it is good to describe this sort of implicit co-adaptation?
I think it might be. So there's different things. I think on the one hand, the way that I looked at co-learning, I mostly assume that the agent is kind of like a robot-like entity, even if it's virtual. And of course, this might be different if it is more like a dashboard AI kind of thing. Or so also within TNO, we're trying to apply co-learning in such situations. So we're also thinking about how does this translate? Is it actually different? But I think in general, it is also useful to reflect on harmful or bad or whatever not effective patterns of behavior. And I think, for example, like a YouTube recommender, does a YouTube recommender assume that the human will also change its behavior? Maybe, maybe not, but it will happen. I mean, we all know it. If you, at some point, you figure out what the algorithm does, so then you know you can influence it, right? Or at least we try to. It doesn't. Sometimes it works. Sometimes it doesn't work. I think it would actually be very interesting if the website would then give back to you, okay, I noticed that you've done this, and that causes me to do this, and then as a given, because sometimes you might be unaware of it. Sometimes you might be. It's really about awareness. If the system would do that, then you can also say, okay, sometimes I just really like to watch these type of videos, but it doesn't mean that you need to start recommending it to me. So actually, this sequence of interactions. Thanks. Tea flying. So this sequence of interaction is not something I want, and then you can. So you can reflect on it then. So I think it might be valuable in the sense it gives a certain transparency. It makes people aware of their own behavior as well, how they react. If the algorithm recognizes that the human changes its behavior to influence the algorithm, they can also say, hey, you're currently influencing me, do you realize? And then you can be like, yes, and I want this, or oh, maybe this is not what I want.
Okay, That was a nice
Not sure
conversation.
if YouTube would do this, but I think it would be interesting.
Yeah, it's difficult to implement for millions of people.
Yeah, so there is also, of course, a lot of the algorithms optimize for a population, kind of, and they put you in a box of you're this type of person, so therefore I behave like this. And I think the perspective I try to take is more, okay, everyone is different, and so I focus of course on teaming kind of tasks where your behavior is influenced by the past interactions that you had within that team. So then it makes more sense to personalize for the person that you are as a unique person given by the previous and not necessarily a box. Oh, sorry, I didn't.
No, that's great. I actually think it's an important point too, Emma. That like, so that's also part of the meaningful human control, right? It's control over the mental model that something, the robot, AI, whatever, has built over you. So that's a nice. And I guess that's also something maybe you can test in your experiments with this ontology, where people can test, I want this, but then all of a sudden you realize, I didn't like that interaction pattern at all. So you can take it out again, something like that.
Yeah, I hope to see that people then save an interaction pattern, and that maybe then the robot interprets that differently as how they assumed it would, and that means they need to like revise it, and that is how you get this continuous improvement and co-learning process.
Okay.
Great. Yeah, so we have a couple of minutes left. So we'll stick around for a couple of minutes more. But I want to thank also, I guess, also on behalf of the audience, Emma, thank you so much for this presentation and the discussion afterwards. It was super interesting. We really sunk our teeth in it. So thanks everyone, and also especially to you, Emma. And yeah, indeed, if you would like to know more about Emma and her work, also her link to her personal webpage and the TU Delft webpage is in the invitation of this meeting. So there you can also find her papers, for instance. So thanks everyone.
Yeah, thanks for the very nice discussions.
Yeah. Thanks. I don't know if so. David and I had a yeah, go for it, David.
Yeah. So now some people are leaving already, but if you want, you can stay around. Because Emma, we've been working, that with Nick on actually translating this to a physical task, and we're working together. And when I say we, it's actually you all and me vaguely hovering in the distance above it, on actually finding a physical equivalent to the kind of co-learning and that you're looking at. But I thought maybe it's nice to share some of the work we did in co-adaptation. And so I have one slider that might be interesting for you to reflect on. And so let me share that while we scare everybody away.
Yeah, we have a meeting with the student for the project tomorrow, right?
That's the different master student, exactly. Yeah, Lucas student indeed.
Yeah.
Very very happy to hear that. And great that you're going on. And so this is the not so beautiful slide that I scrounged together from work of Lorenzo Flipse, supervised by Nick, and also by Sergio Grammatico from DCSC. And what he's doing is he's looking at a task which is using a steering wheel to control 1 degree of freedom left and right, a kind of compensatory or actually kind of pursuit task. It became a compensatory task, right? So anyways, you need to follow a box and minimize the error. So it's a very simple task. But then we also looked at how well do people do this over time when it's just manual control. And then you see here kind of the gain of their control inputs. And we developed two kinds of robot-assisted interaction strategies. And so these are actually, you could say, not emergent behaviors, but imposed behaviors that actually dictate how the robot learns to do this really joint action task. And so one would be to say, well, if humans do less, if we estimate that the human gain is lower, then the robot needs to realize, aha, I should do more, because then I can guarantee joint system performance. And that assumes that humans won't adapt, but or won't adapt to that over time. But what do we find if we actually implement that? Let's see if this works. If we do that, the robot does more when the human does less. Then the first trial, you're still working together, but quite soon the human has very nicely learned not to do anything anymore. And so we know this concept from human factors domain and from slacking. And so, yeah, you know, if the robot will do it, why would you even make an effort? And so I thought it would be nice to show it. And so we also explored what happens when the robot estimates that the human is doing less, maybe then also the robot should be doing less, or vice versa, when the human is doing more, when it's the estimation that the robot should be doing more. So it's kind of a reward for, if you're engaged, okay, I'll help you to do it even better. And then actually what you find is a kind of stable equilibration. It's a new word. It's very beautiful. But so that's actually the idea of kind of trying to empower humans. And the interesting thing is this is all dynamic, so this happens in real time, and all possibilities for weird stuff could happen, but it doesn't seem to happen. So this seems to be something stable. So I was just wanting to share that with you, Emma.
Yeah, very nice.
Yeah.
Yeah, I think it's always very important to make sure that the human feels the need, that there is really a need to collaborate. Why otherwise would you do it? And the more dimensions you add, the higher the chances that this will happen. Yeah, I think, for example, in my experiment with the robot on the leash, so that was a Wizard of Oz, of course, but yeah, some people did like push it towards one side or to the other side, but most people try to find some kind of balanced collaboration, because there was an advantage the robot actually had a capability that the human didn't have, and vice versa. And some of these situations were indeed relatively stable, that people kept having the same balanced strategy. So I think in the paper that I wrote, the second paper that I wrote about that, I also categorized that as, okay, you have stable situations, and then you have triggers that lead to kind of like sudden adaptations of moving into a different stable situation. So it's not always a gradual, it's more of a, now you're in this situation, something happens and you go to a new situation.
Yeah, very complexity theory, right? The boundaries and triggers, and
yeah. By the way, maybe something that you will find interesting as well. Last Monday, I had a meeting with Isaac Kuchuk-Yilmaz. Probably, maybe know this person.
Yeah,
vaguely from name, but
I know her well. She does a lot of human interaction.
Oh, of course, yeah, from Bristol. Yeah, Isaac, yes.
Yeah, she reviewed that paper of my robot on a leash, but it was a Frontiers paper, so she did very extensive reviews of like thousands of words. So what she has worked on and is working on is also like very haptic and like one dimension kind of adaptation. So I think very similar to these kind of things.
Yeah. The role of roles is one of her key papers.
Yeah, so we're also looking into how we might apply these ideas of like having stable situations and then these triggers and learning different types of stable situations, how we maybe can either use old data from her to analyze it in that way, or maybe also set up a new experiment.
How nice. She's doing well? She's in Bristol or something, right?
Nottingham, I think.
Nottingham, yeah, that was it.
Yeah, it was very funny. Because that's a nice thing about these open access, so that you can see afterwards who the reviewer was, and then actually reach out. So.
Yeah, she's great. But then, so unfortunately, we need to move to the next meeting already. So, but thanks, Emma. I just wanted to say one last thing about Lorenzo's data that you saw. So basically, also what happened in with this controller is that basically the mental model of the robot, so the controller thought that the human was terrible at the task, and then at that moment it would completely take over.
Yeah.
So that like you said, but then also the human didn't get a chance to take back control anymore, because you can never be better than a human at that moment. That was an interesting emergence. Like it's a simple engineering, implementation of this controller that led to this, weird behavior where the human had no control at all anymore to take over it. So that was just a little observation that we had also in this data. But anyway, but thanks, Emma, for the presentation and the insightful discussion. This was cool.
Yeah, thanks for the conversations.
Yeah.
And we will see each other tomorrow, I guess.
Definitely. Yep.
Thanks very much. Bye-bye.
Good.
Bye-bye.
Bye.
Bye-bye. Thanks.